Okay, trying to help you guys out with a little advice on a retake for probability B. So take some notes here. If you do the problems with me, you will remember them so much better. Don't just watch. It's really kind of useless to just watch. All right. So if we're going to pick out 4 marbles out of this, let's say, bag full of marbles, and we're going to, well, there's a lot of different ways they could ask the question. If they just ask what's the probability of a blue, there's no reason you'd have to do some complicated thing with, CC over C. If you just wanted probability of blue, you'd figure out that there's a total of 16 marbles, and you'd say 4 out of 16. And that would be a little too easy, though, for our level of test. So what we're going to ask you to do is more like, what if you pick out 4 marbles? 4 marbles. Now, obviously, you could get all blue ones, or you could get a couple blue and a couple red. You could get one of each and then an extra black one. I mean, there's all kinds of ways that could happen. So let's do a specific, if you pick out 4 of them, what's the probability you'll get at least one blue one? You want to memorize that at least one means not 0. We're not going to get 0. Otherwise, we're going to, for sure get 1. All right, so not 0. All right, so if we're going to get not 0, which would be the same as at least 1, blue 1, then let's set up a CC over C. That's the way I describe it. And let's do the bottom first, because to me that helps get you organized and set up. There are 16 marbles, and I'm taking out 4. Now, there's blue ones. And in this case, because I don't ever mention the other colors, I'm just going to say there's other ones. Now, I could have set up 3 separate C's, one for blue, one for red, one for black, but it's easier then to just put the other 2 together as other. All right, so blues, if we don't want 0, we're going to do 1 minus this whole thing, and we're going to set it up for 0 blue ones. So we have 4 blue, and how many do we want? 0. And we have how many other ones? 12 other ones. And now we can start using the fact that we know this and this adds up to this, and we know this and this spot here have to add up to 4. Therefore, it must be 4 other marbles that are not blue. So I would put this in my calculator, and then I just take 1 minus that. All right. Let's do another example like this. Let's say that I wanted at most. That's kind of like at least, but it's completely different. Okay, at most, 1 red one. All right, if we want at most 1 red one, then we want either 1 red or 0 red ones. So we need to figure out first the probability of 1 red one, and then the probability of 0 red ones. You really have to think through, does at most, what does at most mean? At most means we could have 1 or less than that. All right, so I'm going to set up the 1 red ones right here, so that I always do the CC over C for this kind of question. And I have 16 marbles, and I'm picking out 4 of them. And I want 1 red one to happen. So this time, the thing I'm focusing on is red ones. And there are 5 red ones in there. And I said I was going to start with getting 1 red one. So we'll say we get 1 red one. Now again, you can use this little principle here to go, what has to be in this spot? Well, 5 plus what makes 16? This must be 11. All right. So that's the 7 and the 4 together, the blue and the black ones. All right, and then this one plus this one has to make 4. So this must be 3. We're going to get 3 marbles that aren't red and 1 that is. All right. Now it's either that or the other scenario, which is 0 red ones. So then that'd be 5 choose 0 times how many other ones? Well, it was 11, and how do I know that? Really should start with the bottom. We're doing 16 choose 4 again. And then this and this have to make that. And this have to make this, so this must be a 4. All right, now, or means add. We've been pounding that in this whole time. So then we figure out this one, and we figure out this one, and we add them together. Now, there is a faster way to do that. The denominator is the same, and so if it has a common denominator, we can just add the tops and divide by the bottom. So that would just save you a little bit of time. All right, so that's a tough one, but you have to know how to do all of the things I'm telling you are important. You have to know how to do all of them. All right, there's another type of question that we used blanks to figure out. Let's say it's a 4-digit number. All right, how many different 4-digit numbers are there? Let's just start with that. Well, you do choices here. This isn't about what digit, it's about how many choices you have for this digit of the number. All right, so if I want a 4-digit number, and my numbers can be anything from 0 through 9, well, then that's 10 different choices. But a lot of times we're trickier than that. And we'll say like, oh, you can only use the digits 5, 6, 7, and 8. Well, then you have 4 choices for this spot, 4 choices for this spot, 4 choices for this spot, and 4 choices for that spot. You think of it as choices. So that'd be how many different 4-digit numbers I could make by only using the digits 5, 6, 7, and 8. All right, what if I couldn't repeat numbers? Well, then I'd do 4 times 3 times 2 times 1. All right, what if I wanted, and this is the tough kind, the probability that out of this 4-digit number that I have, and let's make it so that it can't repeat too. Okay, so then that'd be 4 choices times 3 choices times 2 choices times 1 choice. All right, let's say we wanted to figure out the probability that the person picked a number that was bigger than, let me say, 7,000. Probability that it would be bigger than 7,000. Well, these are all the things that could happen. So that goes on the bottom. So 4 times 3 times 2 times 1 is 12 times 2 is 24 times 1 is 24. Now, the top is what we want to happen. So we set up choices again. How many choices are there for that first digit? If it needs to be bigger than 7,000, then you can only have a 7 here, or what are my other choices? An 8. There are only 2 choices for that first number. Okay. Now this gets tricky. I have chosen one thing so far. I've chosen that first spot. Now, does that mean that I should just like decrease like 4, 3, 2, 1, and I should go 2 times 1 times 0 times 0? That doesn't make any sense. That's going to make 0 is my answer. So how many choices do I have for this spot? I've already used up one number right here. So there were 4 different numbers I could have picked. So now there's 3. And then there's 2, and then there's 1. Okay, so 2 times 3 is 6, times 2 is 12. So this is 12 out of 24. And that means there is a 0.50, as in a 50% chance the number that the person picked was bigger than 7,000. All right, let's go to this one. If they give you a percentage right off the bat, then you know they're not going to be giving you a simple probability because they already gave you a probability. So if there's a 75% chance that a seed is going to sprout, you may not know this, but you plant a bunch of seeds in the ground, they don't all sprout. So if I go with 75% starting, then what's the probability that at least one of my 4 seeds would sprout? So there's a typical question. This is a binomial type setup. And binomial is where you have a C in front and then 2 parentheses. All right. If there's a 75% chance that something will happen, and this is it not happening, there must be a 25 for that. Right. Now, if I have 4, I have 1 of 4 if I just wanted 1 of 4, and I wasn't worried about the at least part, if I just wanted 1 of 4, then I would go 4, choose 1, and a 1 here, and this number together with this number has to be the total, which is 4, so this would have to be a 3. But I just figured out the probability that it would be 1 out of 4. And the actual question is about at least 1 out of 4. So I just did the probability of 1. Then I'd have to do the probability of 2 for C2, 0.75 to the 2, 0.25 to the 2. And the probability of getting 3, 4 choose 3, 0.75 to the 2, 0.25 to the, let's see, it's got to be a total of, wait, this is going to be a 3. And then this has got to be a 1, okay? And the last one is probability of 4. 4 choose 4, 0.75 to the third, 0.25, nope, to the fourth. Keep messing that one up. These two are always the same, Mr. Server. All right, so then this one's got to be a 0. And now I just figured out the probability of 1, 2, 3, and 4. And it's either 1 or 2 or 3 or 4. So I can do it that way, find out each of these 4 answers and add them all up, and that would be the probability of at least 1 out of 4 working. But wasn't there an easier way? Definitely. If you wanted the probability of at least 1 out of 4, you could say, well, if it's at least 1, then it's not 0. So if I'm going to do not 0, then I want to go 1 minus the probability of 0. So this is 0.75 of it happening, and this is it not happening, so 0.25. And then there's 4 seeds we're going to plant, and here's the probability of 0. I put a 0 here because these are always the same, and then this must be a 4. This would be the probability of not that. Not means 1 minus. Okay, so 1 minus, 4 choose 0, it's 0.75 to the 0, 0.25 to the 4. That's a lot faster than this. You could have gotten these 4 answers, and it's this or this or this or this, so or means add. You'd add them all up. But it's a lot faster to go 1 minus, not 0. All right, and then the last kind here, heavy duty, a mix of area model of probability and expected value. So first, let's just find the probability that if you, let's say we were tossing pennies from a helicopter and they were going to land inside the rectangle for sure, then what's the probability that they would land in the triangle or the circle? All right, so first of all, I find the area of this triangle here, which is going to be 5 times 4 is 20, but then half of that is 10. And then another thing that's that we want would be this circle, and that has a radius of 3 because the whole thing's diameter is 6. So then this is pi times 3 all over, so that was pi times 3 squared, sorry about that, pi r squared, all over 20 times 10. That would give me the probability that I'd land inside the shaded region. Okay, so this is 9 pi. You could change pi into 3.14 and then add 10 and then divide by 20 times 10 is 200. That would work. But we're going to be figuring out a different problem, not just the probability of landing in those. Let's say that this is some kind of crazy contest where if you can hit the triangle, you're going to get $180. And if you can land a penny inside the circle, then you're going to get $200. Now that changes it into an expected value question. Okay, so sometimes we'll say like tickets instead of dollars just to make it less like gambling. And so anyway, if you're trying to figure out the expected value, you need the probability of each thing times the amount you will get if that happens. You got to have every possibility for probability. So what are the 2 things that you get money for? You get money for landing in the triangle, and if you do hit that, you get 180. And the probability of that, well, that one was the one that was 5 times 4 is 10. 5 times 4 is 20 divided by 2 is 10. out of 200. That's my probability of that. Canceling that, that's 1 out of 20. That's like 5% chance. Okay, now the probability of hitting the circle. This one's the circle. This was the triangle. So the circle's probability is, that one was pi r squared for the area of the circle, which would be pi times 3 squared, which would be 9 times pi, divided by the whole thing, which was, again, 20 times 10, 200. I'm going to get the decimal for that. And that turns out to be about 0.14, as in 14% chance of that happening. I'm going to go one more decimal place just to make it a little more accurate, 0.141. Now, how much do I get if I hit the circle? I get 200 bucks. So, now I'm going to take my probabilities times my amounts, and I'm going to put them over here, and I'm going to add them all up and put it down here. So, it was a $9 expected value for the triangle part, a $28 expected value for the circle part. Put them all together, your expected value was $37. Now, what if they threw in one more thing? What if they said, oh, wait, your actual chance to do this costs you $40 to play? Well, you were expecting to win about 37 if it was free to play. And if they charge you $40 to play, well, then you'd lose $3, or let's see, what would that be? $2.80. Okay, so if there's a price to play the game, you have to subtract that from the expected value. All right, so there's an overview of all the types of problems that you're needing to be ready for the test. And that's all I have for you. I'm going to pause for a second here. You know, I've decided I think it would be worthwhile for me to set up one of each problem for you as something that you could try. And then I'm going to go through and give you the answers for those. So you pause me after each problem that I give you, try the problem, because if you're really understanding this now is the time to practice it and make it stick. Okay? All right, so we're going to go back to that first kind, and let's use this same marble setup, and let's have you try to figure out the probability that you will get at most one blue. Pausing. Okay, so I want you to figure this one out. What's the probability you'd get at most one blue one if you pick out 4 of them? All right, hit pause, try this, and then see if you set it up right. Okay, hopefully you've done this. Don't just watch me. All right, so at most 1 means either you're going to get 1 blue or 0 blue. That's what at most 1 means. So let's figure out the probability of getting 1 blue, and that would be, I'm going to do that CC over C thing, and I always start on the bottom. There's 16 marbles total in there, and I'm going to draw out 4 of them. Then I'm going to make this my blue. 1 blue would mean there are 4 blues in there right now, and I want to get 1. And there are 12 things that are not blue, and I want to get how many of those? I can use this. This adds up to this, and that plus this number here has to add up to 4, so this must be a 3. 3 things that are not blue and 1 thing that is blue. Or, and I hope you remember, or means add another CC over C, and that's if we get 0 blues. And that would be 4 choose 0, and to make 16 total, this would be 12. And this is 16 choose 4 again. And then this must be 4, making sure it balances. Those make 16, and those make 4. Yay. Okay, so I'd figure out this probability, and or means add, so I would add those up, and that would be the probability of at most 1. Okay, Now on the numbers question, let's use the same rules again. Let's say we can only use these 4 digits. And let's try to figure out the probability that if you use only those 4 digits to make a 4-digit number, what's the probability that your number would be bigger than 6,000? Bigger than 6,000. Okay, I'd like you to go figure that one out. I'm going to ask you to hit pause and then come back and see how I do that. Okay, the probability of making a 4-digit number with these digits and having it come out bigger than 6,000 goes like this. First of all, you got to figure out all the different things that could happen. Now, you may have been saying to yourself, I wonder if he is going to allow us to have repeating things or not. I'm going to stick to the same requirements from before, that it cannot repeat. So I'd have 4 choices for that first, times 3, times 2, times 1. That's all the possible things that could happen. 4 choices for the first, times 3, times 2, times 1. And that's 24 again. So that's 24 things that could happen. That's the possible. What I want is for the top part to have come out bigger than 6,000. Well, this spot right near needs to be either a 6, a 7, or an 8 would make that work. Okay, so there's 3 choices for that spot. Now, with only 4 numbers to choose from, I didn't pick 3 numbers. I only picked out 1 so far for that spot. So if I've only picked out 1, there's still 3 left. And now there's 2 left, and now there's 1 left. Okay, so that's 9 times 2 is 18 out of 24. And that's my probability that I would pick a number bigger than 6,000. Some of you might be saying, but couldn't it be 6,000? No, because we don't have zeros in our choices for our digits. Okay, so as long as that first number starts with a 6, a 7, or an 8, it would be bigger than 6,000. Okay, one like this seed sprouting question. I'm going to ask you to try this one. What's the probability that you'd get at least 1 out of 2? At least 1 out of 2 of these seeds would sprout. Pausing. Okay, on this one, we need to figure out the probability of at least 1 sprouting. That's either 1 sprouting or 2 sprouting. Now, that's the slow way. You could find the probability of 1, add it to the probability of 2 of them sprouting. But I did not 0 of them, because that's the same as at least 1, not 0. All right, so then I did 1 minus for the not part, and then here I have the probability of you having 0 of them sprouting. And let's see. Actually, my bad. If I'm doing not 0, then this I wanted 0 here. Oh, I see. Yep. I should have put a 0 here, and then I should have put a 0 here, and then I should have put a 2 here. There we go. Now that's the probability of not 0, which would be the same as the probability of at least 1. So this here shows us the probability of 0 out of 2 of them sprouting. Okay. All right. Then we're going to do one last tweak. We're going to take this problem where it was bigger numbers before, and we're going to say, now, how much would you expect to win if the dollar prizes were greatly reduced? And you're not up in a helicopter, you're just like on a ladder. Okay, and you're chucking coins into this area. So if you get $10 if you land inside the triangle, and $5 if you land inside the circle, we still have the same rectangular area that you are guaranteed that your penny will land in. At least you'd be inside of there, right? So now figure out the new expected value with the smaller prizes. All right, I'm going to pause for a second while you give that one a try. Okay, so the cool part is the probabilities remain the same. Okay, because our drawings, dimensions, and everything all are the same. It's just the amounts are different. So for the triangle now, we're going to get $10. That's that amount. So we go 0.05 times the 10. And then the circle, 0.141 is still our probability, okay, because that was pi r squared. And now we get $5 if you get it in the circle. So we got to take our probabilities times our amount and then add them all up. Here's our probability times the amount. I'm going to pause while I go use my calculator. Okay, so for the top one, the triangle, you have an expected value of 50 cents for that part. And for the circle, it is 0.705. Put it all together, and if this is money, $1.21 if I had to round that, because this tells me I should round up. So $1.21 is my expected value. Now, what if, though, there was a cost for playing this game? Let's say it costs $2 to play the game. Well, then you would subtract 2, and you'd have a negative expected value. But I didn't give you any cost to play the game, but that's what you would do if there was. So your expected value should have been $1.21. That's what it's worth to play the game with the new prize amounts. All right, I hope this was helpful. I hope you study more than just this. There is a review worksheet, which was very good. Maybe you just try it again. Try specific problems you know you're weak at. But study a little bit more before you take that retake. All right, have a great day.